In this lesson, we'll focus on the addition of fractions that don't share a common denominator. In order to make things easier to see and develop an intuitive understanding of adding fractions, we will be using some visualization techniques throughout this lesson. Let's take whole numbers like the number 1 and see what happens when we turn them into fractions. Remember, we want to understand fractions better, so we're going to use some interesting visualization techniques. We'll use shapes to show whole numbers, fractions, and to illustrate how fractions are added together. Let each rectangle be a representation of the whole number 1. Let us now divide the blue rectangle into 2 equal parts, and the green rectangle into 5 equal parts. Whenever a fraction has the same number on top and bottom, it equals 1. Think of it like cutting a whole pie on a pizza tray. If you take all the slices from the tray and place them on your plate, you have the whole pie again, which is equal to 1 pie. As you can see, the left rectangle is divided into 2 equal parts, and the right rectangle is divided into 5 equal parts. The fractions below each rectangle represent these divisions. Look at our fractions. The number on top tells us how many of these rectangular parts that divide the whole rectangle are colored in. That number is called the numerator. The bottom number tells us how many equal parts each rectangle is divided into. That number is called the denominator. Look at our rectangles. We can change the fractions by coloring fewer parts. Let's remove 1 blue part from the left rectangle and 3 green parts from the right rectangle. Each rectangle is now an exact visual representation of the fraction immediately below it. Let's now work on adding these 2 fractions. Adding fractions with the same denominator is easy. We copy over the same denominator and simply combine the blue and green parts from our 2 rectangles. The total number of combined parts becomes the new numerator. But when we have different denominators, which one do we copy over? Is it the denominator of 2? Or do we copy over the denominator of 5? The answer is that neither of the 2 values will work. This is because they represent fundamentally different sized pieces of a whole rectangle. To intuitively understand why adding fractions with different denominators is tricky, imagine you ordered a pizza pie cut into the usual 8 slices and your friend ordered the same pizza pie but cut into 16 slices. After both of you are done eating, you try to compare how many slices you ate more than your friend. Can you make this comparison? Since the slices are of different sizes, you can't directly make the comparison of who ate more. Before we can add these fractions, we need to find a common denominator, or a common division of the 2 rectangles. The division we use must maintain the current surface area of blue and green parts within their respective rectangle. In addition to finding a common denominator, we want it to be the smallest possible value. That is, we want to calculate the least common denominator. To find the least common denominator, we'll use a process called finding the least common multiple, or LCM for short. Let's explore 2 ways to calculate the LCM. We start with the fraction that has the smallest denominator, the one on the left in our example. This approach minimizes the number of calculations we need to perform. To find the LCM, we start by increasing the denominator of the fraction on the left by multiples of 2. We keep doing this until the new value is at least as large as the denominator of the middle fraction, which is 5. We increase the denominator of the fraction on the left, 1 over 2, in steps. To keep the fraction equivalent, representing the same amount, we'll also need to adjust the numerator accordingly. Why did we specifically choose to increase by 1 and 2? It's because the original fraction, which was in its simplest form, had a numerator, top number, of 1 and a denominator, bottom number, of 2. As we search for the least common multiple, we'll increase the denominator of the fraction on the left in steps. At each step, we'll add 1 to the numerator and 2 to the denominator, thus ensuring we maintain the fraction's equivalence. Let's now increment to the next multiple by adding 1 to the numerator and 2 to the denominator. Since 6 is larger than the middle fraction's 5, we'll now focus on increasing the denominator of the middle fraction 5. to find the LCM more efficiently. Let's now increment to the next multiple by adding 2 to the numerator and 5 to the denominator. Since 10 is larger than the left fraction 6, we'll now switch back to focus on increasing the denominator of the left fraction 6 to find the LCM. Let's now increment to the next multiple by adding 1 to the numerator and 2 to the denominator. 8 is less than 10, so we continue incrementing. Let's increment to the next multiple by adding 1 to the numerator and 2 to the denominator. Eureka! We've found the least common multiple. Time to add those fractions. Look how we move all the green parts and blue parts from the 2 left rectangles to the single rectangle on the right. That's the same as adding our 2 fractions. The colored parts together represent the fraction on the right of the equal sign. This means that by adding the numerators of the fractions on the left, we get the fraction on the right, which represents the combined colored area. We learned how to represent fractions using rectangles, and how to add 2 fractions together when they do not share a common denominator. In our example, the denominators were 2 and 5, but the good news is that any whole numbers will work. The previous technique of incrementally adjusting both numerators and denominators to find the least common multiple, LCM, achieves the goal, but the process might not be the most efficient. Let's explore a more systematic approach for finding the LCM. Let's revisit the fractions we started with in this video lesson. The technique we'll now explore is called the listing method for finding the least common multiple, LCM. To begin, let's draw a horizontal and vertical line that intersect in the top left corner, just below the fractions. Then, copy both denominators and place them side by side to the left of the vertical line, as shown. Now write the first few counting numbers as illustrated, above the horizontal line. We can add more numbers later if needed. In the first column, write the first multiples of both denominators as shown. Starting with the smaller denominator of 2, list its multiples until a multiple of 2 is greater than or equal to the first multiple of the larger denominator of 5. We stop listing multiples of the smaller denominator 2, because we've already found a multiple 6 that's greater than or equal to the first multiple 5 of the larger denominator. Let's switch focus to listing multiples of the bottom row, until we find a multiple of 5 that is either equal to 6 or greater. We stop listing multiples of the larger denominator 5, because we've already found a multiple 10 that's greater than or equal to the third multiple 6 of the smaller denominator. Let's switch focus back to listing multiples of the top row, until we find a multiple of 2 that is either equal to 10 or greater. We can stop listing the multiples of 2 and 5 now because we've found 10, the least common multiple, LCM. While we could continue listing multiples of 2 and 5, any new common multiples we find would no longer be the least common multiple, LCM. Now let's use the table to modify our fractions. We'll adjust them to have a denominator of 10, while keeping their original proportional relationship. The fraction with a denominator of 2, shown in blue, needs to be multiplied by 5, shown in green. This is because 5 is in the same column as the target denominator 10, circled in green. The fraction with a denominator of 5, shown in blue, needs to be multiplied by 2, shown in green. This is because 2 is in the same column as the target denominator 10, circled in green. Now that both fractions have the same denominator 10, adding them confirms our earlier result. Thanks for watching. If you found this video helpful, consider leaving a like. If you're new to the channel, hit that subscribe button for more amazing videos.